Hello, today we're looking at Glencoe Accelerated Math, Lesson 5-2 on unit rates. So, yesterday we talked about ratios, and ratios were the relationship between two events, or two measurements, or two situations, okay? Today we're talking about unit rates. Well, a rate is a ratio, but that ratio has a denominator of 1 every single time. That's where the word unit comes in. A unit is a single thing. Okay? Unit rates come into play in different situations. The most common place that we look for unit rates is generally when we're trying to figure out what is the best buy for our money. Alright, have any of you guys ever been to a grocery store? Okay, we've been to a grocery store? Good! Alright. How many of you have been in the Gatorade Powerade aisle at some point? Okay, good, everybody. What? So, if we look at that Gatorade or that Powerade, we know that we can buy the giant gallon size. We can buy the 12-ounce bottles. We can buy the 8-ounce bottles. The 12-ounce and the 8-ounce bottles come in, sets of 6 or 8 or 10, right? Okay, and then we have the 32-ounce bottles that are sold individually. We know that we have all these different options for the exact same thing. And as a smart consumer or as a smart shopper, somebody who wants to make sure that they get as much as possible for the least amount of money, we generally do what we call finding the unit rate. That means we find out how much we're going to pay per ounce of liquid. Because believe it or not, the amount that you pay per ounce of liquid is different for every single selling option possible. Okay? So even though we're drinking the exact same Gatorade or the exact same Powerade, the 32 or the gallon size, the 32-ounce bottle, the 12-ounce bottle, and the 8-ounce bottle, Coca-Cola, who owns Gatorade, or do they own Powerade? No. They own Powerade. Okay, sorry. So that Powerade is going to cost a different amount for that liquid based on the different size bottle. You can actually find the unit rate or the price per ounce on the price tag that's at the store. Okay? Every store does it, especially with liquids. Walmart, and I'm not a huge fan of Walmart, I will admit that, okay? But Walmart does a really good job because the right side of the tag gives you the price, and then the left side has that little yellow part, correct? Yeah. Yeah? Okay. That little yellow part puts a different amount of money. It has cents over there. And that's telling you how many cents per ounce you're going to pay. So that gives you the unit rate. That tells you how much you are paying per ounce of that drink. So unless you're buying for a team and you know that you need 20 bottles, could you buy the gallon and pour it into a cup? Yeah. Would it really kill you to drink the 8 ounces instead of the 12? No, it wouldn't. Okay? Shh. So, what we can do, we can use the unit rate. Please stop. We can use the unit rate to figure out how we get the most amount of whatever it is we're buying for the lowest cost. Okay? I'm going to geek myself out here for just a second, okay? My husband and I, we like to go to the grocery store together. Alright? We're at that stage of our life where going to the grocery store together is like a date. It happens. So, we will go, and I'll literally pull out the calculator on my phone and find the unit rates for different things to make sure that we're getting the best deal. I'm going to tell you one more time to stop. Stop. Okay. So, now that you know why we're looking for unit rates, Let's see how we actually calculate it. All right? Now, there are a couple different ways that we can do that. One way is the easy way. It's the way that the majority of the world will calculate unit rate. I'll show you that way. The other way is the way that justifies why the easy way works. Okay? So, if you look, okay, at the top of your book in green, it says proportionality and linear relationships. So we're looking at proportions this chapter, correct? Okay. So what I'm going to do, I'm going to show you how to set up a unit rate problem using a proportion, because that's the justification of why the simpler way works. What I would recommend that you do, solve a couple problems using the proportion so that you get into the habit of doing it that way. And because the remainder of the chapter is based on proportions, and then you can double check using the way that the majority of the world finds unit rate. Sound fair? Yes? Okay. Look at example 1 on page 189. It says that we need to express each rate as a unit rate. So a rate tells us how much we get for how much. Okay? It gives us the relationship. If we have $11 for 4 boxes of cereal, and guys, the cereal aisle works the exact same way. All right, you know that there are 8 different sizes of boxes of, of Cheerios. Okay, there are like 6 different box options for Cheerios. So if we look at example 1, we're paying $11 for 4 boxes of cereal. Okay? I'm going to start by setting this up as a proportion because we're finding the cost of 1 box of cereal. Does it make more sense to figure out how many boxes you get for $1 or how much you pay per box? How much you pay per box? Okay? So that's some amount of money, we'll call that the variable x, over 1 box. The way that we set this up is called a proportion. There are 2 rates, 2 ratios that are set equal to each other. We're going to cross multiply. I like to draw in the little, I call them band-aids because with the variable, my proportion is broken. It needs to be fixed, and how do we fix something? We stick a band-aid on it. So, that means that we have 4 times x equaling 11 times 1. 4 times x is 4x. That equals 11. Divide by 4, because that is the number that is attached to my variable. And x is equal to, I'm cheating, 2.75. Okay? So that means that we are paying $2.75 per box of cereal. I don't know what size box of cereal that is, but if it's a big one, I would love to get that price at my grocery store. Okay? So to put this in the, now, I have a number. I went ahead and put a dollar sign in front of it. Let's put this in terms of the rest of the problem. Because we need to say that that's $2.75 per box of cereal. If we just say $2.75, we don't know what that's in relation to. That could be $2.75 per ounce of Gatorade. That's a lot for Gatorade. Okay? Considering we can generally get like 32 ounces for less than $1. That's a lot for Gatorade. Okay? Depending upon what we're looking at, that's going to depend on, what's expected as our unit rate. Okay? Questions about what we did in example 1? No? All right. Here's the alternate way that we do this.
Give him a pencil.
The alternative says we divide. 11 divided by 4. Is that what we ended up doing here? Yeah. We just set it up as a proportion first. So like I said, I want you to practice a couple using the proportion. You can double check this way. All right? Because eventually we will get to this point. All right? Questions? Okay. I'll give you another minute to write that down, and then we're going to be looking at example 3. Give me a thumbs up when we're ready to move on. Okay, then get it from your group after we're done. Okay. Alright, at least half of each group is ready? Yes? Okay. While I'm erasing, I need a volunteer. Someone please read example 3 to us nice and loud. Yes.
A typical bottlenose dolphin will take about 34 breaths in 4 hours. How many breaths will a bottlenose dolphin take in 7 hours?
Okay, so this problem has 2 ways that we can solve it. Okay? What is this lesson on? Unit rates. So we're going to first find the unit rate, and then we will apply that unit rate to our situation. Okay? Here's what we're going to do. We took how many breaths that we know of? 34 breaths. And that was in how many hours? 4. And we are trying to find, we need to know how many breaths per hour, correct? Okay, so that means we have X breaths per 1 hour. That's what we're trying to find. Alright? So I'm going to cross multiply, putting on my Band-Aid so that we can fix my broken proportion. That gives me 34 times 1 equaling 4 times x. 34 equals 4x. Dividing both sides by 4 to get our variable by itself. 34 divided by 4 is 8.5. So that means that we take about 8.5 breaths per hour. Now what we're going to do, we found the unit rate. What is my unit rate? What? My unit rate is 8.5 or 8.5 breaths per hour. That is my unit rate. because that means we have 8.5 breaths per 1 hour. Alright? We need to find out how many breaths we can expect in 7 hours. So we're going to take that 8.5 times 7. And 8.5 times 7 is 59.5. Now, ladies and gentlemen, how do you take half of a breath?
That's what I just asked.
All right, so, I guess technically we could say that you inhale but don't exhale,
Let's just say.
but,
Just so you can.
but, do we really want to try to figure out if a dolphin is inhaling but not exhaling or exhaling but not inhaling?
Yeah.
No, let's not do that. So we're going to round our answer. We're going to round up to 60 or down to 59. Up to 60. So, we can expect about 60 breaths in 7 hours. What does this squiggly sign here mean? I wrote it in a couple different places. What does that mean? Okay, that means approximately. Okay? Approximately means that we rounded. Okay. If we are rounding, it's not going to be exactly 60. It's going to be about 60. Okay? Approximately 60. Any questions? Ladies and gentlemen, give me a thumbs up, thumbs sideways, thumbs down. How do we feel about the algebra part here? And the salt, just give me thumbs up, thumbs sideways, thumbs down. How do we feel about this part of solving? Okay, good. Thank you. Any last questions? All right, thank you very much.